Hi, everyone, and welcome. Imagine, just for a second, creating a whole virtual world like photorealistic, dynamic weather, sounds, everything, just by typing a few words.
Yeah, and then being able to actually experience it smoothly on a mobile VR headset.
Exactly. Sounds a bit like science fiction, right? Well, today we're doing a deep dive into ImmerseGen. It's this really groundbreaking AI framework that's actually making this possible.
That's right. And our mission today is basically to unpack how it manages to get such amazing realism and run so efficiently, especially on mobile.
And we're digging into the research paper itself for this, the one titled ImmerseGen, Agent-Guided Immersive World Generation with Alpha-Textured Proxies.
It's a fascinating paper. Really shows how AI is changing the game for 3D content creation.
So let's set the stage. If you think about building, say, a detailed VR environment, traditional, it's a ton of work, right? Complex models, textures.
Oh, absolutely. You've got intricate geometric modeling, detailed texturing. It takes ages. And then the big problem comes when you try to actually run that detailed scene in real time.
Especially on something like a mobile VR headset.
Exactly. You pretty much always have to simplify those complex models way down. And that simplification process, it often brings in visual artifacts. Things look kind of blocky, maybe textures get blurry.
Right, and smooth performance just goes out the window. You end up with low frame rates, maybe even just like 7 to 14 frames per second, which is not great for VR.
It's often unusable, frankly. Or the app just won't even load on the headset. You're stuck choosing between looks and performance.
Okay, so that's the challenge ImmerseGen tackled. How did they approach it differently? This is where it gets really interesting, I think.
It really is. They kind of threw out the traditional playbook. Instead of building super complex geometry, ImmerseGen uses what they call lightweight geometric proxies.
Geometric proxies, so simpler shapes.
Yeah, think simplified terrain meshes. And then they use something called alpha-textured billboards.
Okay, alpha-textured billboards. Can you paint a picture for us? What are those like?
Sure. Imagine like a flat image, say of a tree or a bush, but the background around the tree is transparent. That's the alpha channel. You place lots of these in the scene, maybe angled slightly differently.
Ah, okay. So from most angles, it looks kind of 3D, but it's computationally much, much cheaper than a full 3D model.
Precisely. But here's the real magic. Generative AI models then create and apply these incredibly detailed, photorealistic, we're talking 8K textures, directly onto those simple shapes.
Wow, so the detail comes from the AI-generated texture, not complex geometry.
Exactly. And AI agents guide this whole process. It completely bypasses that whole cycle of complex modeling and then painful simplification.
So you keep the high-quality look without the performance hit. That makes sense. It's like using really detailed wallpaper instead of carving every brick.
That's a good analogy. And the result is that the scene representation itself is incredibly compact, very small in terms of data.
Okay, so let's talk about these AI agents. They're doing more than just texturing, right? How does it go from a simple text prompt to a full scene?
Right, it starts super simple. You might type in glacier lagoon, twilight sky, or maybe sandy desert, clear sky, distant dunes.
Basic ideas.
Yeah, and interestingly, they mentioned using an LLM agent like GPT-4o. That can even take your basic prompt and, flesh it out with more creative details. Make it richer.
Okay, so the AI can even help you brainstorm the scene. Then what?
Then other specialized AI agents take over. One selects a suitable base terrain from a library. Others guide that texture generation process we talked about, making sure the textures fit the context.
And they place things, too, like trees and rocks.
Yes, and this is really clever. They use what the paper calls a semantic grid-based analysis.
Semantic grid. Does that mean the AI understands where things should naturally go? Like trees don't grow on sheer rock faces, that kind of thing.
Exactly that. It's like the AI builds an understanding of the terrain and the scene's meaning, so it places assets like trees, rocks, maybe little shrubs, in locations that are semantically appropriate and visually plausible. It looks coherent, not just random.
That's crucial for realism. It's not just about the visuals, though, is it? ImmerseGen aims for full immersion.
Right. It goes beyond just looking good. The system analyzes the scene it just built. Is it a forest, a beach?
Yeah.
And then synthesizes appropriate ambient sounds.
Oh, cool. So like bird song, wind, maybe water sounds.
Yeah, exactly. It pulls from sound libraries to match the environment, and it also integrates dynamic shader effects.
Like what?
Things like realistic cloud movement across the sky or screen space rain effects if the scene calls for it, even ripples on water surfaces. It all adapts dynamically.
Okay, so you get the sights, the sounds, the dynamic elements. It really pulls you in. But the big question, especially for mobile VR, is performance. How does all this actually run?
And this is where the numbers are just well, staggering. They report achieving around 79 frames per second.
79. On mobile VR, using the Snapdragon XR2 Gen 2 platform they mentioned?
Yep. Compare that to the 7 to 14 FPS or failures to launch that you often see with other high-detail methods on the same hardware. It's a massive leap.
Wow. That's genuinely game-changing for mobile experiences. And that efficiency must tie back to the compact scene representation you mentioned.
Absolutely. The scenes use only about 223,000 primitive counts. Primitives are like the basic triangles or polygons that make up a 3D model,
And other methods.
often run into the millions. So ImmerseGen is just orders of magnitude lighter.
And it's not just numbers, right? They did user studies.
They did. And users consistently rated ImmerseGen scenes higher across the board: perceptual quality, realism, coherence, how well it matched the text prompt. In fact, users preferred the ImmerseGen results in over 50% of the comparisons for every aspect they tested.
So people actually felt it was better, more immersive.
Yeah, the subjective experience matched the objective performance gains.
Okay, so wrapping this up, ImmerseGen seems to be fundamentally shifting how we can create and experience these virtual worlds. It's showing that high realism and smooth performance, even on mobile, aren't mutually exclusive anymore.
It really opens the door. Think about creating personalized, super realistic virtual training simulations for almost any skill. Or just, stepping into a dream world you described yourself.
And making that as easy as just typing a few words.
Exactly. The potential is huge.
So, a final thought for everyone listening. What does this really mean for you? Imagine a future where generating and exploring these custom digital spaces is just effortless. How could that change how we learn, how we play games, how we connect online?
It really does feel like we're on the cusp of something new here. Lots to think about.
Definitely. A big thanks for breaking that down for us. And thank you all for joining our deep dive today. We'll catch you next time.